In the previous class, we discussed up to JFET, right? JFET as an amplifier. So today, let's start a new subtopic, integrated circuits, ICs. Integrated circuits. If you have seen a transistor is usually of this size. You can see them by your naked eye, okay? They have 3 pins. You can see them. It's usually of this size. Now this is a size of a single transistor that was made earlier. But nowadays, the size of a transistor is almost 9 atoms. This is the size of a transistor in the atomic scale. It is almost the size of 9 atoms. And Intel, you know what is Intel? Intel is a company that makes CPUs. So in a CPU, in 1 inch square, Intel is packing 1 billion transistors. 1 billion transistors. So nowadays, these transistors have become very small. And by using these transistors, we can make circuits. That circuits are very small. Now the size of a transistor is very small. Therefore, the entire circuit is very small. So we call those types of circuit as integrated circuits. We call those types of circuit as integrated circuits. Sometime you might have seen. If you might have seen a electronic device, when you open an electronic device, in that you might see black color small chips with some small legs. Have you seen? Just like this. So these chips, we call them as ICs, integrated circuits. So within these chips, there are several circuits that are made up of transistors, resistors, and other materials, the other small materials. Have you seen integrated circuits? An IC is a complete electronic circuit, and IC is a complete electronic circuit, which contains transistors, resistors, diodes, capacitors, along with interconnections between them. All made up on a chip of silicon. So on a chip of silicon, we have all of these components together with interconnections to make certain circuits. Pin diagram of an IC is as follows. So when you take a IC, and that IC, you will have certain number of legs. For this example, I'll consider it has 8 legs. So these legs, they have numbers. Using the number, only we know what to connect to that terminal. To count that number, here on one of the side, we will have a dot. So from that dot, we will start to count. 1, 2, 3, 4, 5, 6, 7, 8. So that is how we number a chip. Next point, IC are used in computers, calculators, digital watches, and etc. It is used everywhere. ICs are used. ICs are used in computers, calculators, digital watches, and etc. If you are using it in computer and in digital watches, whatever in between, the probability of using IC is very high, right? So what is the advantage of IC? Why using IC is better than using large circuits? Advantages of ICs. First, you don't need to make any new connections. You don't need to make the circuit. The circuit is already made and it is smaller in size. Circuit is already made. And second, it's small in size. It is small in size. Third, to make ICs, it is very cost effective. It only needs a very small amount of capital. So cost per component in IC is much smaller. Cost per component is much smaller. Both. The circuit is very much reliable. Circuit is reliable. Fifth, it is well protected. Circuit is well protected from dust and moisture, from dust and moisture of environment. So we have especially two types of ICs. Types of ICs. We can classify IC specially into two types. One is analog, the other one is digital. So the first one, linear or analog ICs containing amplifier circuit. For example, operational amplifier. Second, digital IC. Example, logic gates. Digital IC, comma, containing switching circuit. Containing switching circuit. Example, logic gates. Operational amplifier topic. Operational amplifier. In short, we also say it as op amp. Op amp. Operational amplifier. The block diagram. The block diagram of an amplifier of an op amp is as follows. So now we are looking about this analog ICs. Okay, under that we mention an example as operational amplifier. We will be discussing about operational amplifier. So the block diagram of an amplifier, that means it's a diagram. We use a triangle to denote the operational amplifier, and it has two input terminals. It has two input terminals and one output terminal. And we also have a power supply terminal, a positive power supply terminal, a negative power supply terminal. So we give special names for these terminals. So this is positive terminal, this is the negative terminal. So here, this is the output terminal, V out. This is the output terminal. Output terminal. And this is plus VCC. Here we have the minus VCC. So these two terminals is the power supply. Power supply. These two terminals are the input terminals. And the positive terminal, we call it as the non-inverting terminal. And the negative terminal, we call it as the inverting terminal. Inverting terminal. Both of them together, we call them as the input terminal. So this is the input terminals. we can use this operational amplifier in two modes. We call them as open loop or closed loop. The op amp, the op amp is used in open loop configuration, or closed loop configuration, or closed loop configuration, or closed loop configuration. Noted after this. When you're done, let me know. Okay, so next topic, open loop configuration. Open loop configuration. To understand what is open loop configuration, you must know what is closed loop configuration also. So what I'm drawing now, don't draw. I will let you know when to draw. We said we have two terminals. We have two terminals, input terminal and a single output terminal. And then we have two power supplies. We have two power supply. If we give an input, we provide an input, let's say we in, and we get an output. We call this configuration as, so this is plus and minus. We call this configuration as open loop configuration. Then what is closed loop? The closed loop means, so this is our input terminals. This is our input terminals, plus and minus. And this is the output. So here we have the power supply. What we do is we get a feedback. That means we connect the output back to the input using a resistor, back to the negative input. So we call this one as feedback. How do we get a feedback? We do something and then we get the output. So we get the feedback from the output. And using the feedback, what do we do in everything? Using the feedback, we make our input better. So the same thing happens here. If we use a feedback resistor, then it is closed loop. If we use a feedback resistor, it is closed loop. If we do not use any of these feedback resistors, then it is open loop. Hope you got the difference between closed loop and open loop. So under open loop configuration, let's draw Here we provide an input V1 and here we provide an input V2. Let's say this is my positive terminal and this is my negative terminal, and let this be plus VCC and this be minus VCC. We get the output right here. So that is V out. So here, what is our input voltage? What is the difference in our input voltage? Input voltage, input voltage VI is equal, you have to get the difference between these two terminals. We always deduct the positive terminal from the negative terminal. So that is V plus minus V minus. So V input is equal V1 minus V2. That is the input. And here, the output is proportional. It is proportional to the input. Then only it's an amplifier, right? So this is our input voltage. The output voltage is proportional to the input voltage. For output voltage, let us use V naught proportional to Vi. By introducing a constant, I can convert back into an equation. V naught is equal A times Vi. So V naught is equal A times V1 minus V2. So that is the equation for the output voltage in this amplifier. Once you have noted it here. Okay, done. So A, now what type of configuration is this? This is in the open configuration. So we call A as the open loop gain. A is the open loop voltage gain. So what does A give you? You give an input. It multiplies by A times and it gives you an output. So A is the open loop voltage gain. So if we draw the variation of output versus input, we get a variation like similar to this. we expect it to be a continuous straight line, but it is not the case. This is V out versus V in. After a certain level, it's flat. So when you provide input within this region, if you provide an input within this region, only then it gets amplified. Otherwise, you will get a constant value. Did you get that idea? Only in this region, you get an amplification. So what is this output? This output is plus VCC. And this output over here is minus VCC. So for a certain value of voltage, it will get saturated. And for a certain value of negative voltage, it will get saturated in the negative side. So here, I said within this region, within this small region, only it works as an amplifier. If we calculate this region, don't mark what I'm marking now, only we have to drop up to this. I will explain and give you the notes so you understand. So here, this gap, if you check for this gap, it is around 150 microvolts. So if there is a voltage, let's say 0.1, if my input is 0.1, then what can you tell about this amplifier? Will it amplify or get saturated? Will it amplify or get saturated? The maximum value it can amplify is 150 microvolt, which is a very small voltage difference. Then how about 0.1 volt? Obviously, it is going to be in the saturated region. Did you get that idea? So here we are not able to use, although this is an amplifier, we are not able to use this amplifier as an amplifier in the open loop. Do you get it? Operational amplifier cannot be used as an amplifier in open loop. Do you get this point? Already the hand is raised, right? Now let me know. Okay. So draw this. Of this and below write down. This is the variation for output voltage. This is the variation for output voltage V naught with input voltage Vi. For an ideal op amp, yeah, this is the variation of output voltage V naught with input voltage Vi for an operational amplifier, for an ideal operational amplifier. But for practical, V naught max is less than plus VCC, and V naught minimum is greater than minus VCC. That means here this line over here, for an ideal operational amplifier, we have shown it gets saturated and gets the value of minus VCC and plus VCC. But for ideal, it cannot reach up to that. It is slightly lesser and greater than plus VCC and minus VCC. So this is for practical. The next topic, characteristic of op-amp in open. Characteristic of op-amp. Next subtopic. First point, the open loop voltage gain. The open loop voltage gain is very high. Infinity for ideal. The input resistance is very high, and the output resistance is low, and the output resistance is low. For ideal, it is infinity and zero, respectively. So here, so this is a very good character for amplifiers, because the input resistance is very high. It will not absorb a portion of the input. It won't absorb. At the same time, as the output resistance is low, it won't absorb a portion from the output. I think we discussed the same thing in JFET, right? Finally, when we were comparing between BJT and JFET, we discussed why having high resistance is better, because it won't distort the signal. It is not going to absorb any current from the signal. At the same time, when the output is low, output resistance is low, now everything will completely leave. There won't be any leftover. Is that idea clear? Example 1. A is 10 to the power 5. V1 is greater than V2, which is plus and minus. You have to find the minimum value, find minimum value for Vi to saturate. So if we saturate, that means what will be the output?